Hello. Okay, thank you all for joining us today. We have around 1 more minute left, so we'll be starting off shortly.
Bless you.
Okay, I guess we're all here and we can slowly start. First of all, thank you all for joining us today. It's great to see all of your faces here on the last day, and hopefully you'll enjoy what we have prepared for you. Today, we're going to be talking about agents and Copilot, mainly focusing on multi-agent systems, how we can make them smarter together, actually. Multi-agent systems are basically shaping the future of intelligent collaboration, and that's what we're going to be tackling today. First, just a second. There we go. To introduce ourselves, my name is Brian Chilibruk. I'm a senior technical consultant here at Rich International, and here with me today is my dear colleague.
Hello everyone, my name is Massimo Aldi. I'm a senior technical consultant as well at Rich International. Both of us mostly focus on the Power Platform, Dynamics 365, and of course Copilot.
Awesome. Together we have worked, I think, on numerous projects, and what we really try to do is basically transfer our ideas into impactful digital experiences. So yeah, hopefully that's the one experience you'll be having with us today. Before we proceed, do we have any NBA fans maybe in the crowd? Denver Nuggets? Awesome.
Denver Nuggets, but I'm a fan.
Okay, awesome. So since we're coming from Serbia, I think you know about Nikola Jokic.
Oh yeah.
Awesome. So we have some drinks prepared for you, energy drinks, which are actually Jokic branded. They are limited edition to Serbia, so please ask any questions. We'll be giving them off to the best discussion that we're gonna have, so please interact with us. That's the point that we wanna achieve today with this session. Okay, so without further ado, what's our agenda and the beeline for today? First, we're going to try to identify the need why collaboration is no longer optional. We're going to show how the single model agents cannot compete with multi-agent systems anymore. We'll try to generate a solution. We'll showcase the multi-agent system and what it can actually do. We'll navigate the impact. We'll show you the mass in action of multi-agent system. We'll show you how to implement it, making it actually real and coming to life. We'll test the proof. We have a short live demo prepared for you through the Copilot Studio, showing you what it can actually do, how do you set it up, and what's the final outcome. The last but not least one is the future. We want to envision it, what's coming up in the next year or two, and what you can actually expect. As you see, we try to spell out the word ignite over here because we want to ignite the intelligent collaboration with multi-agent systems. So let's quickly outline the objective for today. There are three main takeaways that hopefully you'll learn today. First is the fundamental of multi-agent systems. We'll show you how agents can work together and how actually multi-agents can compete and I think win every time over the single agent systems. We'll show you how to design and evaluate the multi-agent solution, how you can actually implement some real world patterns. There are a couple of them, and each pattern should technically suit your business needs. The last but not least one is how to implement the multi-agent systems. We'll be showcasing two technologies that we have. It's the Copilot Studio and Azure AI Foundry. We have a little bit of everything for everyone. Today, Azure AI Foundry is mainly focused on developers. It's tech savvy, whereas Copilot Studio is mainly oriented for, as Microsoft calls them, citizen developers. It's easy to implement, to work on, but again, you can really make some amazing solutions even in Copilot Studio. So, without further ado, let's jump in slowly. We'll show you what is needed, why collaboration is no longer optional. Let's start with the reality check, the complexity crisis, which is hitting technically every organization in today's day. There are businesses that have challenge working with single model agents. They simply cannot handle all the requirements we have for them today. You'll have a single model agent trying to be your customer service, support, trying to do analytics, audit, whatnot, and it simply cannot handle all of that we are throwing at it. The variables that we throw, the needs, it's growing exponentially, and we simply cannot use single model AI agents anymore. That's why we are trying to start, and the industry is technically pushing into the multi-agent systems. And essentially, throwing more compute or more GPU power at a single model agent is not worth it anymore. The returns are really diminishing. You can maybe get 10% more improvement over the multi-agent system, which is going to use less compute power, and it's going to be way, way better and faster than a single agent. And as Aristotle said, the whole is greater than the sum of its parts. So let's make this concept relatable to the human parallel mainly. We all know that specialized teams outperform generalists. You wouldn't ask your database admin to design your UI, right? So that's what we're trying to tackle here. We'll have specialized single agent, which is working in an orchestrated unit, in a symphony, as we call it, where it's contributing to the greater good, or actually to the whole system. We have metaphor, the orchestra. Every player is playing their instrument, which he knows the best, and all of them are actually playing one fine-tuned symphony. And that's what we are actually trying to implement here. We also have a Michelin star service, for example. You have an expediter, which takes the order, brings them to the kitchen, the chefs prepare the order, it gets quality checked, and then we have the output. And that is a perfect example for the multi-agent system. The expediter is actually our orchestrator in this case, handling all of the chefs in the background, the employees, and the art. We have some statistics over here. There is a 40% increase, or actually faster project completion with cross-functional specialist teams. We have 47% higher efficiency using orchestrated specialization, and 60% less compute power compared to the monolithic or single model AI agents. Now, what are the costs of actually isolating and using only one AI model? There are real business impacts. We have delayed decisions. missed optimization chances, opportunities, resource waste for redundant processing. We're going to be using more and more power with a single model to actually get a result which a multi-agent system could do way faster and way more efficiently. There is also a hidden multiplier effect when three systems do not talk together. We have system A that makes a decision, system B that kind of contradicts that decision 2 minutes later, and system C which uses the outdated data from both this system A and system B. And that's actually what is causing all the bottleneck. We also have some examples of the costs, what it is actually taking a toll on the industry. For instance, our live demo is going to be focusing on a truck brokering multi-agent system. And for that industry, we have 35% of all trucking miles that run empty, because you have to compare the truck, its load, to find the perfect match, and we have routes that are running basically empty. It's costing quite a lot of money, as you can see. We have manual truck and load matching, where people have to actually go and compare all the data daily, and it's happening millions of times only here in the US, and God knows how many trucks are actually running each moment around the world. And also, last but not least, is the unnecessarily burned fuel in these routes, which can be optimized. We can find better paths for trucks to go, which are technically more efficient as well. Now we are actually going to enter the multi-agent system and show you what the multi-agent system is and how it performs. As the quote says, the future of AI isn't a single superhero anymore. It's the whole Avengers, actually the team of agents working together. Okay, let me see what happened now. We might have a small technical difficulty. Oh, no. That's not the multi-agent system we're gonna aim for. This is what happens when you let AI builder train on Arnold Schwarzenegger movies, basically, not using the proper data. No, we are gonna actually be focusing on intelligent collaboration or a teamwork, and that's technically the AI that we have running right now. That's the AI that is helping our industries across the field, the hospitals, education, taking care of your bank accounts. All of that is running currently, and it's actually not saying I'll be back, it's saying I'm watching your back. And that's what we want to achieve with it. So let's reimagine the intelligence as a teamwork. What is actually the max? Those are, as I said, autonomous or specialized agents working towards a shared goal. Each agent has its own expertise, they want to collaborate to achieve the same goal, and none of that can be done if they work alone, basically. And the principle is simple. We have divide, conquer, and collaborate. The task is split across multiple agents. They try to conquer them one by one. And then we have the collaboration where they actually talk between each other, sharing information and contributing to the greater good. And we have the shift happening right now. We're going from one AI to rule them all to the right agent for the right task, which is actually those specialized agents that we have. Now let's see at this equation, so to say. We have a self-healing system that can never actually fully fail because the LLMs are constantly being trained on their tasks, what they are doing, and we're perfecting the agent the more we use it. Then we'll have an expertise without adding complexity. We'll have separate expert agents working in a bigger system. We'll have all of them thinking in parallel, not in sequence. And the last but not least one are the solutions that we get at the end, which not a single agent could discover. All of that is leading us to the success. Now, what is the live concept that we have prepared for you today? It is a truck brokering multi-agent system. We have the orchestrator in the middle. The first agent that we are going to be showing off is the intake agent. That is the agent that is actually going to filter our truck database. Truck database is going to consist of a lot of information where the truck's current position is, what the load type it can carry is, what is the maximum weight capacity, how many experience years does the driver have, when is the next maintenance, and so on. So that agent is supposed to actually find the available trucks, get all the relevant information from them, exclude the ones that are due for maintenance in, let's say, 5 days, so we don't risk that call being damaged while being shipped. The next agent is the load analysis agent. That's the agent that is working on a completely other table where we have all our loads saved. I don't know if anybody maybe interacted with a system called that.com. Is anybody familiar with it? It's a load matching system where you can actually go as a truck broker, find available loads for your trucks, and start basically negotiating to win that load. That's what this agent is working. He's going to get the data from the intake agent and find all the available loads in the areas where the trucks currently are. The next agent is a matching agent. That agent is going to get the data from the first two agents and start matching them. It's going to try to find a compatible truck with a compatible load with its requirements, the weight capacity, and so on. It's going to start matching them and actually providing the user with information which truck can be matched with which load. As you can imagine, if you have 100 trucks, 1,000 loads, it's going to take you the whole day to actually just match them. And when you have a bidding system where you have to bid in real time to win the load, it's going to take a lot of time and you're going to have a lot of missed opportunities. The next agent is...
So the first three agents pretty much cover the core functionality of the specific system. And we also have three other agents that kind of facilitate and help to make the mentioned logic work, essentially. So the first one is actually the geographic optimization. So what this does is it tries to optimize the route as much as possible, trying to avoid late pickups or late deliveries so you don't actually generate extra cost. And yeah, okay, perfect. Now we have the match scoring agent, which this one kind of works in combination with the matching agent. Since, of course, you have multiple trucks and multiple loads possibly in the same area, this agent will pretty much score it based on how efficient it is, based on the revenue and other series of factors, and it will give it a score so that the system can actually give you the best possible choice. Last but not least, we have the route analysis. So this is kind of your live agent getting live data. Its main focus and job is to actually see, once the matching is done, and actually the delivery and pickup is starting, this one will pretty much gather all the information to see if there's any issues, if the route is still valid, if there's any delays, whatever. Its job is pretty much to collect data and feed them back into the system so it can actually improve the whole other agents.
Then we'll have the impact, the actual mass working in the action. We'll have a few talking points when we get to this topic. The first one is the operational excellence. We'll be completely removing the human bottleneck. As I said, if you have 1,000 trucks, 1,000 loads, trying to match them throughout the day, comparing a bunch of columns, the data, it's not going to happen. So that's why we're going to try to actually remove the human bottleneck. The next one is the cost optimization. We're going to find savings through using specialized agents. We're going to intelligently allocate our resources. So basically not using a single model agent, we're going to be using the multi-agent system. Next one is the risk mitigation. We're going to be using a multi-agent validation. What that means is that each agent will foolproof its own results, give them back to the orchestrator, and the orchestrator is going to be the last point of checking for the failure, so the user will not get any, let's say, redundant or incorrect information. And the last but not least one is the customer satisfaction, which we aim for always. The results are custom tailored and personalized for your needs. And as the quote says, this isn't the future of AI, it's happening right now and at the scale. Over here, we're going to have some cross-industry revolution or the use cases where the multi-agents can be actually implemented.
Yes, so we came up with 3 examples, but of course, this can be applied to pretty much every single sector, industry, pretty much everything. So the first one that we came up with is, for example, in healthcare. So the emergency room orchestration, which could help facilitate and improve pretty much, the whole like usage of resources, service, and everything inside of emergency rooms, for example. So we kind of divided this like on a concept level of 4 different agents that you could use. You can use a triage agent that can actually assess the severity in a very short time. So it can kind of like organize priorities of what's happening. Second one is the resource agent, which can actually automatically allocate or assign beds, medicines, or resources that you have available. Third one is the scheduling agent, which could optimize and make the doctors like visiting routes as efficient as possible. And the last one is the prediction agent, which could potentially anticipate if you're going to have a surge.
Everything you're saying makes logical sense. I'm following you step by step. If I could just play devil's advocate for a second, like, doesn't it make more sense, like, some would say, you ever heard of like Occam's razor? Like, the simplest way to get to something should be the simplest. We break it up like this so modularly this way, isn't that more areas for failure?
Well, it depends on the kind of pattern that you cover, that you use. We will cover this very shortly. But technically, so once you actually break it down in modules, only one part could, or multiple could break, but the whole system would still be in place and somewhat work. So you always have to put it on a scale, like you want the whole system to go down and have nothing that works, or do you want just one part to actually fail, but the overall system still continues, going forward and giving you somewhat useful and reliable information.
I mean, do you foresee like internally, like if I'm the administrator, do you foresee like different administrators for each of the agents, or is it like just one person managing it all? Are you getting these from different vendors, or are you using multiple vendors? Or?
Yeah, okay. So this depends on what kind of, let's say, project you're working on. For example, let's use like a company. You're building in like an internal agent for each. You're building one big agent for the company that is breaking down like by sections or departments. In that case, ideally, you will have one overall admin, but it would have sense that each department kind of manages their own part. If we're talking about something a little bit more important, like healthcare, insurance, or whatever, my recommendation would be you'll have one overall admin that takes care of the whole system. But at the same time, we'll cover it as well. You could, this is more on the foundry level, because you can use custom agents outside through REST APIs and whatever. You could use external services that are maintained by different companies.
Sure.
Great question. Thank you for that. Yeah. All right. Our next use case of the business suite that we're going to focus on are the financial services. Intelligent fraud prevention system. We can have 4 different agents. One is the transaction agent, which is actually scanning the transactions in real time, trying to find patterns for any misuse. That agent is going to feed the behavior agent, which is trying to detect any deviations. If he flags them as true threats, we'll have the network agent, which is going to start scanning the cross-account relationships, trying to find the source of that transaction, and the last but not least is the learning agent, which is going to adapt those new patterns daily. So we'll actually have fraud prevention that's going to happen in milliseconds instead of days, where it's actually going to risk people's money and savings as well. And the last but not least one.
The last one is the manufacturing one, which similar to the others. You can have multiple agents, of course. One that actually manages the suppliers. It can monitor and advise you, how things are going with specific vendors or suppliers. Second one is the weather agent, which could technically keep track of world events or weather events. For example, hurricane is, in one part of America, it could actually tell you, okay, you might have issues with these vendors, so please use these other ones. And that kind of ties together also with the alternative agent one. And the last one is the inventory agent, which can keep track of your stocks and tell you, hey, you have to, you're finishing these products, you should reorder them, and so on. Like the possibilities are technically, infinite. You can do whatever you want.
And another quote, every industry is actually becoming a software industry, and every software industry is becoming a network. And that network actually represents the multi-agent systems. Now we'll talk about the competitive edges. First and foremost is the speed. The parallel processing compared to sequential training, thinking is not even a question. Parallel processing will beat the sequential thinking every time. We have the accuracy, specialized expertise in each domain, and as you asked the question, they'll have agents which you can use one by one. You do not have to use them as a whole system, or you can use or utilize the whole system which is working together. So you actually can have accuracy on two different levels. You have the scalability. You can add agents. We let's say, build our system horizontally, so we do not add any complexity. You're just adding more agents or new agents for some new functionalities or logic that you need. And the last and the most important one is the adaptability. You can swap or upgrade your agents without changing or overhauling your whole system, so you do not have to start from scratch. It's basically like Legos. You take one part out, put the new one in, and that's it. Now, making it real.
All right, so now we covered more or less the whole story. Now we're going to look a little bit more on the technical side of things. So we're mostly going to focus now on the Microsoft ecosystem, which currently we have two main platforms that we can use, which is Copilot Studio and sorry about that, and Azure AI Foundry. Both of these platforms have kind of the same use, but in different ways. Both of them have their own pros and cons, and we'll cover that, but it's not about which one is better or which one is worse. It's more about which one fits your needs in that moment. So the first one is, of course, Copilot Studio. That's the big talk of this period. It provides a very easy and friendly usage. It's a low-code solution. You don't have to be a developer technically to use it. It can be any financial business consultants. It can be pretty much anyone inside of your own organization. It has, because of the low code and the UI friendly interface, essentially, it's very fast to actually adopt and develop. You can have an agent up and running in a matter of days. If you actually know what you're doing, probably even in hours. And one of the biggest actually benefits of it, it's right out of the box, it has pretty much full-on Microsoft ecosystem integration. You can use pretty much, you can connect and use all the tools that you are already using. And as we said, this is more for for business users. Even though that's not a limitation, developers can play with this and go crazy with it to a certain extent.
How many of you made an agent in Copilot Studio? Okay, awesome.
How many of you use Power Automate, for example, or Canvas apps? So
the experience is the same.
Yeah, in theory, if you can make a Canvas app or a flow, you can make an agent. Now, the second option that we have and we're presenting today is actually Azure AI Foundry. This one is a little bit more complicated. It is suited for developers. And as it says, it's an enterprise-grade code-first platform. It gives you great flexibility and freedom to actually do whatever you want. It can be implemented wherever you want. You can actually modify or create your own structure. You can use virtual networks. You can use whatever you want. So it gives you a lot of flexibility. One of the biggest advantages of Foundry is actually you're not limited to the models that Copilot Studio gives you. So that's GPT, and since like 2 weeks ago, you have the two Anthropic ones as well. With this one, pretty much you can use your own. You already have a set of models you can use. You can also use your own. You can modify them and extend even the existing ones. Now, the plot twist is these two is that you don't actually have to choose one or the other. They can actually coexist, and we will cover that as well. The important thing is you have to understand when to use one and when to use the other. And that decision is very, very big, because if you make the wrong decision at the start, it can lead you to kind of like a downfall of a lot of wasted time. Because then you will notice you reach a certain point and then maybe you have to start over. All right, so we came up with a little small, easy to read table that kind of highlights the differences with the two. We won't go through all of them because we're taking up a lot of time. That was more important. So the main part is the learning curve. As you can see, Copilot Studio is very gentle because it's a visual experience. It's mostly drag and drop with a little bit of prompt engineering, which they even made that pretty simple with instructions. You can pretty much tell it in a normal, natural language what it should do. On the other hand, you have Foundry that it has a very steep one because of all of that freedom and the coding aspect of it, which is in Python or C#. You pretty much can modify every single aspect. And that one kind of ties together with the flexibility. Copilot Studio has a constraint on it, it's limited. You have to stay inside of the boxes, or the box that Microsoft set up. So they tell you, you can do this, but you can't do that, and you just have to deal with that reality. But with Foundry, you have no constraints, you have no limits. You can pretty much, whatever you envision or want to do, you can simply do it. You will require resources and time to do it, but you can. Now, for the best four, so we kind of identify the fields where you should use one or the other. Copilot Studio essentially can cover up to 80% of every person's need, which is essentially a standard conversation. It is very great to have a normal flow conversation between the user and the AI. It can cover most of the standard operations, so creating data, creating records, updating data, fetching, querying. It can do pretty much everything that you need. But there is sometimes that you need something a little bit more complex, especially working with big data or having when you have a lot of mixed data, a lot of entities that are working together, you might hit a limit with Copilot. It simply cannot process that kind of complex logic. So you might need to move over to Foundry. But we will cover that after as well. So the cost models, I wouldn't focus much on it, but as it says, one is pretty much subscription-based, so you can expect and you can predict what the cost is going to be. But on the other hand, you have Foundry that's consumption-based, which, if done efficiently, it can be good. It doesn't have to be crazy expensive. But one small mistake, like you leave, if something goes in a loop or something, it can generate a huge cost on it. Last but not least, the maintenance. As we were saying before, Copilot Studio is mostly on the business user side, so anyone can go in the system and actually add a part, fix a part, update it, whatever. On the Foundry part, you will need a dedicated team of developers to actually work on it. And most likely that will also be, you will need Python developers, you will mostly need Azure engineers or DevOps, and so on. So it actually requires a full, IT team on it.
We'll have the hybrid approach now, and basically showing you what is the best of both worlds. Copilot, as Massimo said, it's user-facing, conversational level, quick integrations. You do not have to basically write any APIs. The connectors are right there, and we have 1,400, I think, right now. Business logic orchestration, it's native. You do not have to be setting up anything too much by yourself. Azure AI Foundry, heavy computation agents. You can dedicate special resources on your Azure platform to basically tackle the heavy stuff. Custom machine learning models and complex decision engines. Again, tech-savvy, more developer-oriented, but still a very powerful tool. And again, paired with Copilot, which can be your, let's say, receptionist, and Azure, which is the one that's doing all the heavy lifting in the background. They can make a best basically match for some heavy use cases. We can connect them, REST APIs, Power Automate, Azure Functions, out-of-the-box functionalities which are still in preview, coming soon. It's amazing. I mean, we can still make a lot of useful stuff with these.
Correct. I mean, ideally, what you would aim for is, as I think I said before, it will be 80% deployment on Copilot Studio and 20% on Foundry. Of course, again, depending on the project, how complex it is, but to maximize, or to minimize actually, sorry, the cost is you mostly want to focus on the Copilot Studio part, and then just the complex logic or complex functions that you need, you will develop that in Foundry.
Now we have some architecture patterns. Those are the three big ones I mentioned at the beginning, and technically each one of them has to be carefully analyzed. You have to pick up your requirements and find a suitable pattern for yourself. First one is hierarchical work manager worker. We have one orchestrator that coordinates basically a team of specialized worker agents. Next one is a peer-to-peer or collaborative one. We have agents that work independently and that share their state or that common layer, which technically can be Dataverse or any database we want, or some middleware. The last but not least one is the event-driven or so-called pub-sub one. Those are the agents which subscribe to events and they react independently. So you do not have to waste resources by constantly having a system running in the background. When an event occurs, they'll fire up and start doing their logic in the background. Since I think we're a little bit running out of time, we can fastly cover these, basically a little bit more in detail, and then we can go straight to the demo.
So I'll cover these very quickly. If any of you have questions, you can do that after, I guess. So the first one is the, as Brian said, hierarchical one. So how it works is essentially you have one master or orchestrator agent that will essentially know when to interact with other child or sub-agents. Essentially, he will call pretty much worker A gets back a response, then he moves to C, to B, and then to C, and so on. This is great when you need centralized control and decision maker. So you have essentially one that coordinates all the other agents that you have. The second type is the peer-to-peer. So what this does is essentially you have a central context or central information, and to that information you will have multiple independent and autonomous agents. So what they do is essentially, like for example, if you're using Dataverse, you can look at like update for a record. So if opportunity is created, agent A will come into play, it will check, it will create the products for the opportunity, then agent B can create the invoice or the receipt or something, and so on. So they all work together, but separately. They will have some sort of trigger between them that you can set up, and that's it. Last but not least, probably one of the most complex ones out there. One thing that we didn't add is that pretty much these three patterns cover around 90% of everything that's developed today in production. You have multiple patterns, like 20 or something more, pretty much, but they're all kind of variants of these three. So this is the last one, probably the most complex one. This one essentially has to be the term, like kind of a middleware bit in between, which is the event bus. It can be the event bus, event grid, what else do we have? I think the Power Platform webhook, and so on. Essentially, you have two different layers, which one of them is the publishers. So that can be users, applications, pretty much anything that generates an update of the data or generates events. That event will go to the event bus, and the event bus will know what agent to interact with. This is specifically great if you need completely async communication. This one, as I like to say, it's kind of like plug and play, because the publishers can come and go as well as the subscribers. You can just continue adding on top, and it won't, interfere with the whole system. This is you basically how scaling on the cloud level actually works. So this one, if you have some huge system, this is your go-to. Now, we came up with a small little decision tree that could help you identify what you actually need. We divided this like in 3 steps, and then we have the 4th one that's kind of like an extra optional one. So the first question that you have to ask yourself is, do you need a conversational interface? What that means is you need an agent that actually interacts directly with your user. So if that's the case, Copilot Studio is your way to go, since most of that is already built in by, out of the box. The second step is, do you need the custom models or heavy compute? So are you processing something complex and heavy? If that's a yes, you will need Foundry. The last one is, you have developers. You have IT, a dedicated IT team. If you do, Foundry is the way. If you don't, you can still try it, but you will hit a wall at some point because it starts to get pretty complicated. And the last one, which kind of simplifies everything, if you're already in the Microsoft ecosystem, if you're already using the SharePoint, Deliverse, Teams, Outlook, and all of its products, it's probably a good idea to start at the beginning with Copilot Studio. Don't go, Foundry all the way at the beginning. You always have time to change afterwards.
And the moment we have been all waiting for, the demo. We're now going to turn on the presentation, and we'll show you what we have actually developed and ready for you today. It is the case that we have talked about. It is the truck brokering agent. Let me just zoom in a little bit. Easy to see. So we have the truck brokering agent. The truck broker is actually our orchestrator in the current setup. We have multiple agents running in the background, which the orchestrator calls. We'll give you a sneak peek of our instructions, what it actually does, what we wrote and told him to do. As you can see, and maybe you have even heard by a couple of days here at the conference, we use the, let's say, bullet list for the instructions. You can use Markdown as well, but we found this to be the most efficient instruction set and the easiest to follow. We can instruct him which agent to call, when to call him, how to call him, and in some specific scenarios which we encounter, we told him what not to do. That's also important through the testing. Of course, AI has to be ran through multiple tests. It's basically hit or miss, you start over again, and then you tell him what does he need to improve on or what not to do. If you go back in our setup for all the agents, we have multiple connected agents working together, and they are all actually standalone agents. In Copilot Studio, you can have a child agent inside of an existing one, which basically does everything that you tell him to do from its parent. In this case, we have standalone agents which are getting called, and they can actually work, as we said in your question, they can work as standalone agents. You can use load agent, fuel, route agent, basically completely as a standalone agent and chat with them without using the whole system. And that is actually the best part about all of it. Each of them is connected to our Dataverse data source in the backend, where we have truck and load information, which is basically going to work upon. Each of these agents, everyone has like their tools, so you do not have to do anything in the orchestrator, just write the instruction set and how to call each agent. Now we'll start with a simple prompt to tell him to find available trucks. Find available trucks and basically to match them with loads that are suitable for those trucks. Trucks and match them with suitable loads. Now he'll fire off. He'll start to recognize the intent behind our message and start actually calling the appropriate agents in the background. Now the Wi-Fi might not be the best, so it might take a little while to finish. From our testing, with around 20 plus records in each of the truck and the load agent, it usually takes around a minute. But if you actually do the math, it's quite a lot of comparison that is happening in the background, and the person, I do not think, could finish this in an hour or at least more. First agent fired off, it's the truck agent, which finds all our currently available trucks, which are not hauling some other load or whatnot. The next one is the load agent. It gets past the data from the truck agent, which is actually trying to find loads that match each of the found trucks. As you can see, as it is running, we can see all the outputs, and the demo failed. Can you imagine that? We'll start over. It does happen sometimes. We did have a recorded demo, but we want to show off.
Yeah, just to add, so most of the settings and features that we're using are still in preview. So we noticed that, a lot of things that yesterday wasn't working, and you don't touch anything, the day after works.
Yeah.
So
we were listening to a lot of keynote sessions, and what we figured out is that basically, hey, we actually implemented in this demo a lot of the features which basically came out a few days ago, so we have to give it a little bit of time to stabilize, but hopefully this run will now finish our whole process. So as I said, the truck agent finished its job, passing all the data to the load agent, which is trying to find available loads for each of the available trucks that have been found. We are using a deep reasoning, since we do have to compare a lot of data to match the perfect load for the suitable truck. So we do have to specify a reasoning or use reason word in our instructions, which actually fires the deep reasoning model. I think with GPT-5 that is not a requirement anymore, it will happen automatically, but in this case we do have it.
yeah. The nice thing is with this activity map, you can actually follow the reasoning that the model is doing. I mean, you can see all the data before it actually gets sent out, so you can actually follow somewhat what is happening.
You can click on these actions and they will show you technically what is happening in the background. This one is running right now, so we cannot see it. But we told him, hey, calculate the distance for the matched truck and the load, how much time will it take, at which speed, the fuel consumption, the best route to take. It will actually generate a Google Maps link for us, so the driver can directly click the link and start following the route to that load. We can find basically how it is thinking, and that are the most important steps when you have to troubleshoot your agent. You can click in here, see the reason. If he is doing something wrong, you can go back into the instructions and tell him, hey, do not do that, do it the other way around. We got our response in, I would say, around a minute and 15 seconds. As you can see, he found two trucks. Truck 5147, it's a tanker truck located in San Antonio, matched one load with him. It is also in San Antonio. Delivery location, he found the miles to the pickup. Since they're in the same town, he said it's basically 0 miles. You can extend this logic with using longitude and latitude information, so you can actually specify the direct pinpoint on the map to calculate the exact distances. Approximate distance, 430 to 450 miles, drive time, how much fuel will be consumed, and in the end we have the Google Maps route as well. Below is the truck, which does not have any available loads found, basically. So any of the criteria that the truck had, the loads did not match them. If we click on the Google Maps link, it should technically lead us from where we are, San Antonio to yeah. So it created a route for us, which we have to follow. As you can see, we actually intercepted this message before the agent replied to us. You can do that with setting some custom or system variables in the backend, so you can intercept the message and modify it for your end user if you want. You can add some text format it differently, use replica cards, whatnot. What we did is, in the end, we just asked the user, do you want to assign found truck to the found load? What it means is if you have a, sorry, go ahead.
So do you actually need to write any code to connect to the Google Maps?
No,
service?
absolutely not. We can show that to you. We have one agent which we told him, hey, you'll get a pickup this location and delivery location. Give us Google Map link. That's all he had to do, and he automatically generates it. Thankfully, it's easy to generate a Google Map link. He has to still find the pickup and delivery locations, but yeah, it is rather easy. Yeah, go ahead.
Can can each agent within the system that's creating this use different knowledge bases?
Yeah, definitely.
So, we kind of mentioned that, but maybe too fast, because I mean, we're kind of rushing to everything else. So, when you actually create a child agent, you have two types. You have the connected agents and the child agent. The child agent is essentially like a light version of agents, which resides directly inside of the solution of the parent agent. So what that means is that it will essentially reuse like 80% of the settings of the parent agent. Like I think the tools, knowledge, and pretty much everything, model, everything else comes from the parent. You can only pretty much specify the instructions and what that child agent should do.
Okay.
But-
And what if your prompt, what if the prompt that you put in doesn't need, let's say there's 5 in the system, and it doesn't need number 3. Is it smart enough to reason to skip 3 and go to 4?
Yeah.
We can show you a use case. We can just finish this full process. We can show you the use case where you can actually.
That's one thing. To finish, so we covered the child agents, then you have the connected ones, which are actually full-blown independent agents.
Right.
So in that case, it will have its own tools, knowledge. You can go crazy. One uses GPT-5 and the other 4.
Sure.
I mean, if you mix and match, sometimes it can, go crazy, but it will be like that.
So basically, we asked the user a question. If we have a system in the background, hey, we want to assign the found truck or trucks, if there's multiple of them, to the found loads. User has 2 simple questions, yes, no. If you click yes, he's actually going to go into our database, find the available truck that has been matched with the load, find the load, and actually assign them together. So for keep-taking purposes, you can go back into your CRM system, whatever, Dynamics, and actually see what's happening with your data. And that's the sweet spot of all of it. The MCP, which is also coming soon, you can tell him to do all of that with a simple instruction. You do not have to go create a Power Automate code, whatever. It will do all of it in the background by itself. It will take a little bit of time now to find these records and basically assign them together with the lookup field. So when you open the load record, which was identified, you will see the assigned truck to that record as well. I think we'll get the link as well in the message, so the user can directly open those and see what is happening in the background. Should finish now, and we can then try the actual question when you asked. We can use the truck broker agent in this case, which is the orchestrator. We can ask him any question that we want. He'll recognize the intent and call the specific agent and not go through all of them. So that's the best thing about it. You can have the whole system, but you can still use only separate or isolated parts of it.
And then once I have my system set up, I have all my agents, and it's packaged in this one deal, I can then embed that agent for my sales team at like the Teams channel, or I can embed it somewhere else, and that's like the packaged agent.
Yeah, so essentially what you would do in this case is you actually just embed the orchestrator or the parent agent.
Yeah, the parent agent, right?
Because at that point you will have the parent agent that will take care of everything else for you. And maybe we can see that after you can just go to channels and you will have, based on the security or authentication method issues, you will have some channels and some you won't.
Of course, live demo, it has issues, but essentially, what you will get to this point, you'll have to trust our word, is that we'll get a message that hey, he finished everything, and we get a link basically directly to our CRM system or some backend system that we have to show the records that it matched. Now, to show you the other use case, since we can technically use the system for whatever, we can target route agent specifically. So we can tell him, show me the best route from New York to, let's say, Boston. He'll now recognize the intent and call only one specific agent that you need. Again, the Wi-Fi is a little bit slow, but hopefully.
I mean, one of the benefits of this is actually like, let's say that at one point you want to switch from Google Maps to OpenStreetMap, something. You don't actually have to open, the huge agent that contains all the logic. You only target the route agent directly. So it will be also much cleaner and easier to maintain.
This can also be embedded in a custom web application, right? Even if
Yes.
it doesn't live in
Correct.
the Microsoft ecosystem.
Correct. Depending on the type of agent that you have and the type of operations that you're doing, you will most likely, if you're using authentication, so you're getting or running data in some SharePoint, Canvas, whatever, you will have to use Azure, like 100%, because you need the app registration to use the Microsoft authentication layers on the side. So because you'll need pretty much the user or the service account to authenticate, so it can actually establish connection to your data.
Okay.
But if you have a, easy or like easy conversational one, or one that just uses like web APIs, you can pretty much host it whatever you want. I mean, you don't need that registration. You can use the Microsoft Bot Framework library, which is in JavaScript and React. You
Okay.
put the connection string, and then you can play around with the interface, and it just goes.
You do have like a lot of options which you can go around. You can even go as creating your own framework, which we have actually done. It's a fully customizable framework for embedding agents on your website, in your apps, whatever you want, which gives you a little bit more control actually when you do have something custom running in the background to stylize the chats, the colors, fonts, whatnot, to match your design. But yeah, your hands are basically untied to do whatever you want.
If you go that approach, my advice is use the React libraries.
Okay.
Because they allow you to actually intercept messages before, so you can really like personalize it on the front end part. With the JavaScript, you still have like the store, and you can manage the events, but you can't really pause it, so you have to get a little bit creative.
Okay.
So yeah, as you can see, we got only a route agent that was invoked in this scenario. So that's what we said. You can invoke any agent in the whole the whole system as well, and that's the best part of it. Once you set it up, you can just swap out one agent with the other. You do not have to rebuild the whole system over and over again. One other part that we want to show you is the knowledge base. So as you can see, the broker or the orchestrator agent does not need technically any knowledge sources in this particular case. All the knowledge resides in the child agents or the other connected agents. For instance, let's open the load agent. Go from here, the load agent is going to be here. So the load agent, we can see its instructions, and this is probably the heaviest or the one that does all the heavy lifting of the other agents. You can technically use only this agent or use the orchestrator to invoke it directly. When we go to knowledge sources, you'll see our two databases that we have connected, truck and freight load. If you open one of them, you can actually help him out a little bit, so he can actually go around everything, and we can write synonyms. Synonyms are going to help us when you're writing your prompts. It's actually going to help the bot itself to focus or look a specific field when you are mentioning it in the instruction set. If you have worked with Dataverse, you do know there are some logical names happening in the background. But for instance, if you give him a synonym for the current location, when you click on it, you can add more than one synonym, which is actually going to help you better identify columns which the agent should focus on. And that is one of the things that you can actually do to make him more precise.
One more thing to add is when you're adding knowledge, or actually even child agents, you will see you have a description field. In most cases, like all of us do, you see a description field, you don't give it any importance, right? But in this case, that description field is what actually the orchestration or orchestrator agent uses to know which knowledge to use. You can use the name, of course, but the more detail that you put in that description, so you say, this file contains this, and this, it will really help the orchestrator to identify and to know.
Yeah, actually put in mind and tell it exactly what it's for, what it's do. You are an agent
Exactly.
and such.
I mean,
So you get full context.
what I found like very useful is, especially when you're creating the instructions and everything, just think as an agent as a toddler, and you have to give it really straight instructions. the more you go precise, the more you go strict, the better it is. The better it will, work. One thing I also mentioned, I mean, the good thing about using especially the new orchestration feature is you don't have to go crazy with the topics. In the way, I think this whole system, we have one.
Yeah, we have really one topic that does some of the heavy lifting. That's the part that failed, that it should have responded with a link to the records. But yeah, did not literally touch any topic, anything, everything is handled through the agents themselves.
Then, of course, if you have to use adaptive cards and so on, so you want a more structured approach to asking the questions, then you can still always fall back on the topics itself.
Alright, that leaves us with about 2 minutes more, I think. Here are some QR codes. You can visit our website. We do have blog posts where we quite frequently actually post some of these, topics which we discussed today, some tips and tricks. So do follow that, and you can also follow us on LinkedIn. Any other questions, maybe? Yeah.
Maybe not specifically for the demo, but maybe from more of an IT management perspective.
Mhm.
So we've been learning for the last few days, listening a lot about AI and agents and all the exciting things that they can do. So I'm thinking, is there no risk involved? Is there no need for us to, because people can be self-sufficient, business can be self-sufficient, they don't need IT to do all these things. So is there no need for us to have some kind of control, some kind of a framework on how we're using it, let's say in case of some critical processes, especially if you're in like a complex organization, or can we just open up the buffet and just free for all and everyone just does whatever they want?
Depends on the use case. So what we recommend is always to start simple. Build literally one agent that does one task for you. Then you can start building upon it. But for your question, you should have some kind of a governance model which you should follow, and that's what we are working on currently in our company as well. How to implement safely the AI agents. You do need some kind of a security, for instance, which databases or tables should it access or should it not? Which files in SharePoint can it see or not? So you do need some kind of a setup. Of course, IT department has to get a little bit involved in there. But in general, we are trying to make as I said, a document or a general governance document with best practices how to follow it. So please stay tuned for our work.
Maybe just have like a, I don't know, agent portfolio or something to see which agents do we have, what is it doing, where is it collecting data from, and who's managing it, because if one person is managing, they quit. Who's gonna keep it going and things like that?
What we do in those cases usually is service account. So it's not tied to a specific person. You'll have your credentials always available in the backend for you. So anybody can, the admins can access that account, but it does not ever get turned off.
So which are the data sources connected with this system?
We had 2 data sources, basically. It's all in the Dataverse. So we have 2 tables, and that's it.
But technically, you can use whatever you want. You can connect to your SQL database, you can use a JSON, you can use an Excel file, CSVs.
Just hoping to hear my little joke is soda.
Go ahead. You want the money or the feature?
It's this one.
Perfect. Is this from Slovenia?
It's from Serbia.
Serbia.
It's specific for Serbia only. We are the competitor player, so.
No, yeah, he's awesome. He's my second favorite player.
Yeah.
Yeah, he's awesome. Thank you for this. I'm not even gonna open it. I'm gonna put it on my wall.
Yeah.
Right.
Thank you guys. Listen, I gave you a follow on LinkedIn. This was good stuff.
Awesome. Appreciate it. Thank you so much.
So yeah, just finish pretty much. You can use whatever you want.
And how does the pricing work for this?
That's a complicated part. So,
But we can discuss it over here, so we don't take up the room. Yeah, we can approach us. And thank you all.